Martin and I are recording a video for the review questions for Module 9, and this video starts with question number 4. Will you read it for us?
What does VSEPR stand for?
So we usually say VESPR.
Yeah, it's the same.
But it's not actually spelled VESPR. So it stands for
Valence shell electron pair repulsion.
So this is a theory about how we can tell how the structures of molecules will look based on the geometry of their electron pair, what the angle of their repulsion and bonds will be, right? So it's a theory in the way that many scientific ideas are theories. Okay, it's very good working. It agrees with our observations. We can't prove that it's true, but it seems to work well. So that's what we're working with currently. Okay, can you read number 5, please?
Explain the VESPR theory in your own words.
Okay. So what is the purpose of VESPR theory, Martin?
The VESPR theory states that molecules will attain whatever shape keeps the valence electrons of the central atom as far apart from one another as possible.
Okay, so VESPR theory says that the electron pairs are going to want to stay as far away from the central atom as possible. That way we can predict what the bond angles will be and what the molecules will look like. Okay, number 6, please. Oh, sorry, you can finish writing down number 5. Such a kind teacher. I'm going to go ahead and look at number 6 and read it out for us. Why are the bond angles in a pyramidal shape smaller than the bond angles in a tetrahedral shape? Okay, so a pyramidal shape and a tetrahedral shape are both types of tetrahedrons. Okay, in the pyramidal shape, the molecule is kind of missing a leg, as you can think of it. And so instead of having 4 legs around the central atom, it has 3 with a non-binding electron pair. Okay, so because of this, the electron pairs are have a different angle. So what is the angle in the pyramidal molecule, Martin? What did we say the bond angle in the pyramidal molecule was? You can look at that chart if you want.
It's 107 degrees.
And how about in the tetrahedral?
109 degrees.
So one is a bigger angle, not by a lot, right? Okay. So in the pyramidal bond, they're not pushed as far apart. Okay?
Yes.
So, yeah, there's no non-binding electron pair in the tetrahedral form, and so they have a different bond shape. Okay. Sure.
Explain the difference between polar covalent bonds and purely covalent bonds.
Okay, so what's the thing we have to look at when we're talking about whether they're polar covalent or purely covalent?
A purely covalent bond is a covalent bond in which the atoms are shared equally between the atoms involved. The electrons are shared. A polar bond is a covalent bond in which the electrons are shared unequally between the atoms involved.
Yeah. Okay. So we have to look at electronegativity as well, right? You can't always tell from the shape if it's purely or polar covalent. You have to look at the electronegativity, and we'll actually discuss that in the next question. So we're going to stop this video and come back with the next question.